Okay, so today we're going to be learning about antiderivatives, which is in chapter 4, section 1 in your textbook. Okay, so basically for an antiderivative, the definition is a function f is an antiderivative of f when uppercase f, when the derivative of f of x equals the lowercase function f. So basically all that means is you're stepping back a step. Instead of taking the derivative, you're taking the antiderivative. So you're trying to find what that equation would have been previous to taking the derivative of it. And an antiderivative is just like this, big F of x plus c, and c is your constant, and we'll go into that later. But we know when you take the derivative of a function, if you have x squared plus 2, we know when we take the derivative, we just get 2x plus 0. So when you take the antiderivative, you need to always plan for that constant. We don't know what that is, but you just need to put a plus c. So that's equation for an antiderivative. Antiderivative is also a synonym for indefinite integration. They're the same things, just different ways of writing the problem and solving it. So indefinite integration is shown through this formula. We have the kind of S figure of f of x dx. This is basically read as the antiderivative of x, or the antiderivative of f with respect to x. This dx is what dictate what we're taking the antiderivative of, which is big F of x plus c, which is just antiderivative. So indefinite integration is just antiderivatives. Okay, so if we're going to work some out, we have y equals cosine x plus 2. Well, we know that if we're going back a step, we know that cosine x is the derivative of sine x. So that's where we start. So we have y equals sine x. Now for 2, if this was the derivative of a function, it would just be 2x. And if you think about it, to check your answer, you can work down. If you took the derivative of sine, that's just cosine. And 2x is just 2. So you can check. Okay, now if we had something like y equals x to the 5th, and they're asking for you to take the antiderivative of it. Well, when we're doing that, you have to bring the power down. So we start with, it would have been 1 power higher. So you know that we're going to have x to the 6th. But since this doesn't have any sort of numerator or denominator, we know when we bring the 6 down, it needs to cancel out. So the only way for it to do that is to have a 6 in the denominator. So that would be your antiderivative. And to check, we'd have, when you take the derivative of this, you'd bring the 6 down. So those two would cancel out, and you'd get y equals x to the 5th. So that works. Now, say we're given something like this, y equals 6x to the 3rd. So again, we're going to start with y equals 6x to the 4th, because we know it has to be 1 power higher. And again, since there's no denominator, we know that the 4 needs to cancel out. And the only way for the 4 to cancel out is to have a 4 underneath. So if we were to solve that, if we were to find the derivative of this, when we bring the 4 down, it cancels out, and we are left with y equals